Hi all, this is Bharatraj. I am from Institute of Aeronautical Engineering. I am pursuing BTech first year CSE A section. Today my topic is about define connected graph and disconnected graph with examples. First of all, we see what is connected graph. A graph is connected with any two vertices of a graph are connected by a path. It is called connected graph. A graph in which we can visit from any one vertex to any other vertex is called as connected graph. In connected graph, at least one path exists between every pair of vertex. For example, in this diagram, we have A to B connection and B to E and E to D and D to C and A to D. So this is the connected graph because here at least one path is existing between equal vertices, equal pair of vertices. So this is connected graph. Now, uh, another graph. In this graph, we can visit from any vertex to any other vertex. For example, A to B and A to D and D to C, D to F and F to E. We have all vertices are connected in any other vertex. There exists at least one path between every pair of vertex. Uh, there consists every path between every pair of vertices. Therefore, it is a connected graph. This is an example of connected graph. We will see another example. In this diagram, we have vertex 1 A and vertex 2 B. The path is the AB and we'll see AC. Vertex 1 is A and vertex 2 is C. The path is A to C and ABC. We have two paths. Now we will see A to D. Vertex is 1, vertex 2 is D. Therefore, we have three paths like A, B, C, D and BC. Now we will see vertex 1 D, BC. We have BCA and BC. Now we will see vertex 1 C and vertex 2 D. We will only one path because CD is connected. There is no another vertex. This is another example. Now we will see what is disconnected graph and some examples. A graph is disconnected if at least two vertices of graph are not connected by a path. In connected graph, the at least one vertex will connected in a pair, but in disconnected graph, at least two vertices of graph are not connected by a path. If graph G is disconnected, then every maximal connected subgraph of G is called a connected component of G graph. A graph in which there does not exist any path between at least one pair of vertices is called disconnected graph. A graph in which there does not exist any path between at least one pair. If there is any path, then it is called as disconnected graph. If there is at least have one path, is called disconnected graph. So these are two difference. Now we'll see an example. Uh, Look at this graph. This graph consists of two independent components which are disconnected because it is not possible to wish from the vertex of one component to another vertex of the another component. So therefore it is the disconnected graph. Now we'll see another example. Here we have two diagrams. These are not disconnected, not connected with each other. So this is disconnected graph. We'll see some paths. First we see A to B. We have only two A to B. For example, we take vertex A and vertex C. We have no available any path. For example, A to D there is no available, and B to C there is no available, and C to D we have one path. So this is a disconnected graph. Now we'll see the applications of connected graph. We have four applications, that is network topology, social network, and transportation networks, and computer science algorithms. First of all, we see what is how the connected graph is useful in network topology. Connected graphs are used to represent the topology of the network. The nodes in the graph represent the computers or other devices in the network, and the edge represent the connector between them. In social network, the connected graphs are used to represent social networks such as Facebook or Twitter or any other applications. Uh, the node in the graph represent people, and the edges represent their relationship with each other. This is another application of connected graph. We'll see the third one, that is transportation networks. In connected graphs are used to represent transportation networks such as roads or railways. The node in the graph represents cities or towns, and the edges represent road or railway lines or connecting them. The fourth one is computer science algorithm. Connector graphs are used to solve many problems in computer science, such as finding shortest path between 2 points or determine whether a graph is bipartite, that is, can divide it into two sets of nodes. These are the four applications of connector graph. These four are frequently used. These are the applications of connector graph. Now we will discuss the applications of disconnected graph. These are the applications of disconnected graph. There are two common, that is in connected and disconnected. There are two applications are same, that is network topology and social network. In these two, they will use both disconnected graphs and connected graphs. In network topology, they use the disconnected graphs are used to represent the topology of the network, such as physical layout of computer and other device connected by various types of links. Compared to in connected graph, it represents to computer or other device in network. But in this, it is devices are connected by various types of links. The second one is social network. In the social network, we see say Facebook, Twitter, and edges are the relationship. But in the disconnected graph, are used to represent social networks such as relationship between people in a community or an organization. The third point is it is image segmentation. In disconnected graphs are used in image segmentation algorithm to identify distant region in an image. This is very important. The final one, the fourth one is path finding. Disconnected graph can be used to find paths between 2 points in a graph, such as finding the shortest path between two cities on the map. These are the four important applications of the disconnected graph. They are topology and social network and image segmentation and path finding. If you observe, the application of connected graphs and disconnected graphs are little bit similar compared to two, that is network topology and social networks. Yeah, thank you.